30. Read the following paragraph and answer the question that follow. Types of lenses and their combination. A convex or converging lens is thicker at the center than at the edges. It converges a beam of light on refraction through it. It has a real focus. Convex lens is of three types: double convex lens, plano convex lens, and concavo convex lens. Concave lens is thinner at the center than at the edges. It diverges a beam of light on refraction through it. It has a virtual focus. Concave lenses are of three types: double concave lens, plano concave lens, and convexo concave lens. When two thin lenses of focal length f1 and f2 are placed in contact with each other along their common principal axis, then the two lens system is regarded as a single lens of focal length f, and 1 by f equals to 1 by f1 plus 1 by f2. If several thin lenses of focal length f1, f2, fn are placed in contact, then the effective focal length of the combination is given by 1 upon f equals to 1 upon f1 plus plus 1 upon fn. And in terms of power, we can write resultant power P equals to P1 plus P2 plus plus Pn. The value of the focal length and power of a lens must be used with proper sign consideration. Now, first part. Two thin lenses are kept coaxially in contact with each other and the focal length of the combination is 80 centimeter. If the focal length of the one lens is 20 centimeter, the focal length of the other would be A minus 26.7 centimeter, B 60 centimeter, C 80 centimeter, D 30 centimeter. So here the correct option is A minus 26.7 centimeter. Here we have net f equals to 80 centimeter and f1 is given 20 centimeter. So we, as far as the paragraph, we have the formula 1 by f resultant is equal to 1 by f1 plus 1 by f2, and we have to find the f2. So 1 by 80 equals to 1 by 20 plus 1 by f2. So 1 by 80 minus 1 by 20 equals to 1 by f2. So here it is 80, it is 1 minus 4 equals to 1 upon f2. So this will be minus 3 by 80 equals to 1 upon f2. So f2 will be equals to minus 80 by 3, that is 3 to the 6, 3 6 are 18, then 3 6 are 18, 6 are 18, that is 226.7 centimeter, and the negative sign is already there. So f2 is minus 26.7 centimeter. So it is a concave lens, and the correct option is A. Second option, a spherical air bubble is embedded in a piece of glass. For a ray of light passing through the bubble, it behaves like A converging lens, B diverging lens, C mirror, D thin plane sheet of glass. Correct option is a diverging lens, yani B. So here is a bubble. The refractive index of the air bubble is, let us say, mu2, and the liquid is mu1. Again here it is mu1. Then since this mu1 is greater than mu2, so this will act as a concave lens, that is the diverging lens. So the correct option is B. That you can also have with the lens maker's formula. You can check it also with the help of that. If you find problem, then you can write in comment box. Third part, lens generally used in magnifying glass is a single concave lens, a single convex lens, combination of convex lens of lower power and concave lens of lower focal length, D, plano-concave lens. Here the answer is single convex lens. That in case of simple microscope also we have also explained it, that the magnifying glass is a single convex lens. So the correct option here is single B, that is single convex lens. Now fourth part, the magnification of an image by a convex lens is positive only when the object is placed at its focus F, between F and 2F, C at 2F, and D between F and optical center. Now fourth part, the magnification of an image by a convex lens is positive only when the object is placed at its focus F, between F and 2F, C at 2F, and D between F and optical center. So the magnification of a lens is given by V by U. So this M will be positive only when V and U are having the same sign, either both positive or both negative. So both positive cannot be, because U is always negative. So that means V has to be negative. So V is negative only when, if you have drawn the 6 cases, so that is only possible when the object is placed between focus and optical center. So if it is placed at focus, it is not correct. The image is at infinity on the other side. If it is between F and 2F, again it will be beyond 2F on the other side, that is positive. And if it is at 2F, then image is formed again at the 2F, so again it is positive. And D is between F and optical center. So this is the correct answer is D, when the object is placed, so it forms in the same side. So whenever magnification is positive, means virtual image is required. In case of the virtual image, the magnification will be positive in case of the lens, and so the U and V will have the same sign. So correct option is D. 30th fourth odd part, a convex lens of 20 cm focal length forms a real image which is 3 times magnified. The distance of the object from the lens is A, 13.33 centimeter, B, 14 centimeter, C, 26.66 centimeter, and D, 25 centimeter. Option is C, 26.66 centimeter. Here we have F is equal to 20 centimeter and the image is 3 times magnified real image. So when the real image is there, so it is negative magnification. That magnification is negative, that is it is -3. It's not 3 only. And we have to find where the object is, distance of the object from the lens, where the object is placed. So that you have to calculate. So these are the 3 terms in which they are related, m equals to f upon f minus u. So here m is minus 3, f is 20 upon 20 minus u, so it is minus 60 plus 3u equals to 20, so 3u equals to 80, so u equals to 80 by 3, that is 26.66, or you can say 26.7 centimeter. So it is at this distance, so you will be always negative 26.77 centimeter, but you have to tell that how much distance it is placed. So it is 26.7 or 26.66, because the option is given this way, so you have to choose this option, that is the C option. So correct is C option, no need to round off.